Good evening, everyone, and good afternoon to folks in Europe. So I'm Sanchayan. I'm gonna be speaking about multimedia using GStreamer and Rust. So quick intro about myself. I work at Asymptotic. We are an open source consulting company, primarily providing services around GStreamer and Pipewire. So I'm primarily from an embedded systems background. First 10 years I wrote C, but last 5 years or so I've been writing primarily Rust and also a bunch of others. I also organize the Rust and Haskell meetups in Bangalore. So quick agenda list. Basically, it's divided into 3 parts. We're gonna go through an intro to GStreamer. What does Rust bring to GStreamer, and then we end up with seeing a bit of code of what that looks like. So what is GStreamer? GStreamer is primarily a multimedia framework. You can think of it as a library or a framework. What it allows you to do is basically build media pipelines to achieve any kind of media-related task. So this can be media editing, this can be some video editing, audio-related tasks. You can think of streaming or recording pipelines, anything in the domain of media. It has bindings for various languages, and it works on basically all platforms: Linux, Android, Windows, and Mac. Some of the softwares that are written or use GStreamer, you might have seen some of them, or maybe are using a few of them. The most interesting part is the first one, which is basically the LIGO Observatory. They use GStreamer, but GStreamer at its core, like I mentioned, it's primarily about data flow. So they don't do anything with media, but they carry out analysis of their whatever data they collect around gravitational waves using GStreamer. But they don't do anything with media because the GStreamer core is actually media agnostic. So it's primarily about building data flow pipelines. So very simple example, what does a pipeline look like? So we have 2 pipelines there. GST launch is basically a command line tool which helps you to basically test simple pipelines on the command line itself without writing any kind of code. The very first pipeline that you see, video test source, there's an exclamation mark in between, and then you have an auto video sync. So what's that doing is basically it's launching a pipeline where you have a video test source. That video test source is basically going to generate a test data. It's just video test data, and then it's giving to the next element, which is a sync, which is basically going to display it on your monitor or whatever display device you have. So GStreamer has the concept of elements. You can basically think of GStreamer like Lego. So you can take different elements of blocks and use it to build whatever kind of media workflow that you want. So there we have 2 elements, which are the video test source and the video sync. And the exclamation mark is in between is basically linking those 2 elements. It's establishing the data flow that needs to go from the test source to the sync. Similarly, the next one does the same thing for audio. So there is another tool called GST Inspect. What does that allow you to do is basically to look at the a brief description of what the element does. So for example, here I run GST Inspect on video test source. You can see it prints out some description. It says it creates a video test stream. And if we look at the end, there is something called as a source path. We will see what's that. Another thing that will come a bit later in the slides is that hierarchy that you see. That also we will briefly touch upon later. So let's look at just a bit more complex pipeline. What this pipeline shows is basically if you have a OGG encoded media file, which might have video or audio, it shows the pipeline for that. So we have a few elements or blocks there. There is the file source. The file source is basically going to read from the file that you want to basically decode and maybe play out primarily. The next is going to a demuxer. What a demuxer basically does is it splits out into elementary strings. So basically it will take the OGG encoded file and it will split it out into audio and video, assuming it has both components. If it only has video or audio, it will only give that to the next. So assuming the file that you gave has both, the demuxer is going to generate 2 pads. Pads are basically, you can think of them, if you have ever worked with electronic circuit boards or breadboards. You can think of them as the legs of a circuit end or a start to the next. So, and data basically flows through those pads. So it generates two pads. One is going to be audio, another is going to be video. On the top, you see is there audio pipeline. So it had an audio component. We plugged in a decoder for that, and then it goes to the audio sync. So this is going to play out from the speakers. And then on the bottom, you have the video part where it goes to the video decoder, and then that's going to play out from the video sync. So we have basically these elements of blocks. Each of them is an element, and you can basically string together elements to basically achieve a different workflows. Like I said, here the workflow is basically you are decoding an OGG encoded file and then playing out the video and the audio through your speakers and the monitor. We will also see the same pipeline in code at the end of how you write that code in Rust. So now let's come back to Rust. So why Rust? In media, one of the primary components is basically parsing. You parse a file, a media file, you don't know what's going to come in. So we care about safety there. We also care about performance, but primarily more so safety. And some of the other things, one of the things that is important for me as such is the low cognitive overhead that Rust brings. We'll see what I mean by that. The second reason is, as such, if primarily those of you who have worked with C or those who haven't, you know that C doesn't have a standard library. But in the GNOME world, if you are using like the GNOME desktop, or if you are somehow interacting with that ecosystem, the primary standard library is glib, and glib provides something called as gobject. Gobject is a way to have an object hierarchy kind of a model within C, to have object-oriented programming kind of capabilities, but without and within the C world, without resorting to C++. So we have the object hierarchy that we saw when I showed you the GST inspect output. That's where this comes in. So if you see that it starts from gobject at the top as the parent, and then all the elements of the blocks that you build are basically going to derive from that. Then the other part is basically when we are working, if we are writing C code, GStreamer primarily started back in 2000 and it has all been C primarily. If you write that C code, a lot of the times you have to basically work around with references. Gobject has reference counting capability. So if you take care of reference counting, basically what you will do is like ref, unref. When the ref count goes to 0, it will be freed. So that kind of a facility Gobject provides. But if you're working with C, that is something you would have to do manually, like call ref if you wanted to increase the ref count, or call unref to decrease the ref count. And Rust kind of, with its borrow rules, it takes care of that automatically, where if something goes out of scope, unref automatically happens. So that's one of the things where it gives you low cognitive overhead, where you don't have to worry about references manually. Now let's look at a very simple code of where the immutability part of Rust really helps. So here we have got a simple code. You need not understand what caps are really. They are basically capabilities of, they describe what data can flow between two elements. So for example, you cannot give audio data to an element which is expecting video. So that's what capability is described. And here we are just trying to build a capability object. So we have video X, we are saying that it's going to be a raw video, and we have some parameters with that. And we are saying we want to mutate it. The remove structure part says there is some kind of mutation that you want to do with that. If you try to compile this code, Rust right away does not allow you to. It says to be able to remove that, to be able to operate on that thing, the operation that you want to do, it should have been mutable. So let's go to the next step and see what happens if we now declare that thing as mutable. So now you will see it's mute caps. Let's run, if we run this code again, it still says it cannot borrow as mutable, and it complains that it needs the deref mute. So what is that exactly? So there is another pattern which comes in. Before just declaring mute is not enough. We need to check, we need to actually get a mutable reference. so that I can have a direct mute at the end. So there is an extra call now where I say caps get mute. This is sample code, so there is an unwrap there. But basically, ideally you would check it. So there is a caps get mute, which will give me the mutable reference. And then if I try to operate, it still says cannot borrow as mutable. So there is still something missing. So now we have one additional pattern where we had the unwrap before, but now I'm actually checking that I have I can actually could get the mutable reference, and then that worked. So the previous line of code, sorry, this is a bit slow. So this code basically won't give you any error. So Rust immutability basically helps to make sure that we are not mutating anything that we actually don't have a reference to, unlike in C where you might try to try to mutate something which shouldn't have been mutable in the first place. So now we saw the pipeline, the media pipeline, which was demuxing or decoding basically OGG file, encoded file. How does that look like in Rust? So if you want to write that pipeline in Rust, how does that look like? So
hello.
Yeah.
Sorry to interrupt. Can I interrupt you?
Yeah, sure. Yeah.
So, I mean, I don't have any understanding of the multimedia. Can you explain me how the memory safety part can help us in multimedia? I mean, that part. I don't know this code level because I'm just studying Rust now.
Okay. So when you get a file, you don't know whether it has, let's say, the specific extension OGG or whatever to denote that it's that specifically encoded file, but there's no guarantee. It can be some random payload. There is no guarantee like. So anytime you read a file, you have to parse it first to actually check whether that file is actually encoded, the encoding with the encoding that you're expecting. Encoding is basically, you never work with raw video generally, you don't transfer raw video, they are always encoded so that you save on bandwidth. So it's going to be encoded, it's going to use some encoding, there are various kind of encodings, we saw only one. But basically you are going to have to parse the file. So that's basically an unsafe operation. You don't know what you're going to get.
Okay.
So there is where the Rust type safety and comes into picture. So that the parsing that you're doing, that's one of your primary operations. It's also performance sensitive. So that's where the Rust is going to help you in making sure that you don't do something like, okay, that payload that you're passing, it's not correct. It was actually malformed. Maybe the injector put something so that you had an out of safe bounds. But with Rust safety, so that you can't have, it has bounce check and all that, you won't run into those errors. So if you see a lot of the new codec libraries, they are now being written in Rust instead of C. So that's where Rust helps.
Yeah, thank you.
Okay. So we are going to see what the code for that pipeline looks like. So the first line basically declares the file source block. That's the block that's going to read from the file in some chunks. So maybe 4K, 1K chunk, whatever. The next line declares the demuxer, the thing which is going to separate out the file into its audio and video components to be decoded separately. Again, this has unwraps, just example code. And then there is something called as, we have what in Rust basically some of you might know or is a closure. Now there is something called as pad added there. What that pattern is, the demuxer, the file that you give, it's not always that it will have both audio and video. So you are not going to know what is going to be actually there at runtime. At runtime when you start decoding the file. So that pad added is a callback which will call your closure a function on when the actual stream is detected. So if a audio stream actually comes, then only, or if a video stream comes, then only that closure will be called. If for some reason your demuxing operation might also fail, then all of that will not be called. So that closure block that now starts, that will only be called, that is something which will happen at runtime only. So that closure is, you're gonna enter, we have something to check like, okay, we have the pad and what are the capabilities of the pad. I'm gonna check capabilities, I wanna describe the media that is coming to me. So I'm gonna check what are the capabilities are. If I detect that a video is there, so you can see I have some check which says, check the capability for the specific string video. If it's not video, then it will be audio. So if there is a video, I plug in the video decoder or the video sync. If it's going to be an audio, I plug in the audio decoder and the audio sync. The specific names that you see, Theora and Vorbis, they are decoders specific to the OGG encoding. If this was something else, it would be something else, but that's not very important right now. So depending on what you get, you plug in the blocks, and then I have some queue elements primarily to take care of buffering. So there is a buffer before the decoder, and then there is a buffer, before the demuxer, and there is a buffer after the demuxer. So I plug them in the pipeline that I'm constructing. You can see there is a pipeline add call. There are some other checks. The other important thing is I'm linking them. So all the elements that I added, all the blocks that I'm adding, they are first added to the pipeline through that pipeline add many call, and then I'm actually linking them through that link, through those three link statements. The queue is linked to the decoder, or basically the demuxer. Then that is linked to the queue again, and the queue to the sync. And so the closure has ended. Basically, to start with, I would just add the file source and the demuxer and nothing else. And then the rest of the code that you saw so far happens when something is actually detected. And GStreamer basically allows you for debugging as well as for analytic purposes to actually inspect the pipeline as well. So you can generate dot pipeline graphs, convert them to maybe PNG, SVG, and then view. So this is an actual dump of the pipeline code that if you run, that it will generate. It just looks a bit different, but it is primarily the same as the previous slide with just the buffering added with the queues in between. So just some statistics, like I mentioned, GStreamer primarily started around in 2000 and has been, all the core and everything is in C. But last few years, a lot of the new stuff is now getting written in Rust. So these are just some of the statistics to show that a lot of the new work is primarily going in the Rust area and not in the C. So the GStreamer core is all stable. Let's say if you wanted to write a block of your own, you would now write it in Rust, and the statistics basically reflect all that work going in. So this statistic is taken from the talk which happened at the GStreamer conference this October. There's a link below if you are interested in that. If and when you do get your hands on the slides, these are some of the resources. If you are interested to look at the code itself, the last one links to the code sample. And yeah, that's all I had for the talk, and I guess if we are open to questions, I'll have time for that.
Anything online?
No. Thank you.
So I have one question.
Yeah.
So what's a good place to get started in the media streaming place?
Sorry, what's that?
What's a good place to get started with Rust and this media?
Okay. So one would be, you can look at the existing projects which are using Rust. So some of the new projects that have come in, I don't recall if they're in C, but they would also be in Rust. So some of the new projects which are based on Rust, like Clapper, Showtime, they are using GStreamer. There are at least two which are in Rust. There is Amberall. So few of them, especially quite a few in the GNOME ecosystem, they are being written in Rust. So you can look at those to get started in there. And from there, as you can, after getting the basics idea of how a pipeline works, you can basically start building anything that you can think of. So you can think of a video editor, you can think of a full-fledged player like VLC, anything else, anything that you can think of.
Including something like a web conferencing thing.
Yes, yes. So for example, we have built web conferencing related recording pipeline solutions for our clients before. So yeah, like for example, a lot of them use the WebRTC technology, which is what Google Meet uses. And GStreamer has excellent support for WebRTC.
Thanks.
Yeah, thank you.
Thank you.